Most organizations today, use at least a 256-bit encryption, which is pretty damn good. Some of the more sensitive ones may even use 512. But even with 256-bit encryption, it's close to impossible for the average attacker, average hacker, average criminal to break encryption. So that's not the way data gets stolen, right? Data is stolen because they steal credentials, find a path in, find a vehicle or a channel that you couldn't or didn't protect, that lets them get to the data. Our point is, there's not a single organization out there when you talk to them that will not tell you that they're not using encryption. They're all using encryption. The challenge is that encryption today for data is encryption at rest, meaning it only works when nobody's using the data. So take this case of a database, right? They all write encrypted data to disk. No doubt, nobody can make a copy of the disk or make a copy of the database file and walk away with data. That doesn't happen. But when a process, user, or a query gets to the database and say, I want to run a query, that data that's presented to the thing automatically is unencrypted or in plain text. So if you're an attacker, you're not trying to figure out how to make a copy of the disk. You're trying to figure out how to execute a query on the database. So because you can get all the data you want. What we do, what our approach is to say, how can you protect the data that's being used in queries, which is what drives the business process. That's our patent. That's our approach, is keeping the data encrypted while it's being queried, processed, or used interchangeably, whatever term you want to use. That's the level of protection that we bring. So now if somebody were to come in and actually get to the data in the database, make a copy of it, not at the disk, but the table level, they will still end up with encrypted data, not with plain text information like what happens today.